Welcome back to the Intro to GIS video lecture series. In today's video, we're going to be introduced to some of the basic topics of spatial analysis. So we'll be using the Spatial Analyst tools, and basically we'll put ourselves in a hypothetical situation where we need to do some terrain modeling and viewshed analysis and several other types of spatial analysis. So we're going to kind of move out of the overlay vector world. We're going to jump into the raster world and learn how to do overlays and models in a very similar way. So what I want you to do to get started is to go down here to Lab 8, and I want you to hold on a second. There we go. Sorry about that. I was listening to my recording while recording. Okay, so we'll go down, and what we're going to do is we're going to click on the Lab 8 lab document here, and I'm going to actually download that as a separate document because I like to have it full screen. Okay, and then the other thing that I want you to download is, if you go back to the labs folder, I would like you to download the census zip file because we're going to need to get some data out of that. Okay, so we'll hit download. Alright, and that's a little bit of a big file, so it'll take a minute, but we can get started here without it being done. Okay, so if we go to the Word document, for this lab, I want you to imagine that you've been hired by the New River Valley Planning District Commission to provide geospatial resources for a new proposal to build a cell phone tower near Claytor Lake. And so what they want is your advice as to whether or not they should allow the company to build that cell phone tower at that location. So some citizens are excited because they'll get better cell phone reception, better signal. In turn, they'll have faster internet and be able to, maybe stream their YouTube or what do you call it, Netflix videos. But on the other hand, some people are upset because the tower is going to be visible by a lot of people, and they think that this could have a negative impact on tourism. And for those of you who aren't familiar with the area, Claytor Lake is one of the only lakes in the region where people go boating and fishing and swimming and other things. So it's a big tourist destination. So as the consultant, they want you to give you their opinion, and they've requested that you do a couple things in specific. So the first one is they want you to create a viewshed map that shows all the areas that are visible from the tower. And we can extrapolate that if a place is visible from the tower, that those same places could see the tower. So this will give us, one, a little bit of an idea as to the service area of the tower for cell phone reception, but then also we could think about how large of an area is impacted by that, where people might have negative opinions regarding the pollution to the viewshed. So based on the permit, we've seen that there's a proposed tower location. We got an X and a Y coordinate, and there's also a proposed height of the tower, and these will be some input variables for our model. And to run that, we're going to have to go out and we're going to have to download some data. So we're going to have to get a DEM, which is a digital elevation model, from the USGS Seamless. They also want a map that shows soil type. Maybe different types of soil are better to develop on than others. Then they want a map that shows us the slope of the property where the tower is proposed to be. They also want a map that shows us the aspect of the map. So is it north, south, east, or west, or of the tower? Which way is it facing? And then they've also requested that we kind of compute the number of acres that are in the viewshed, but we want to limit this to Radford City, Montgomery County, and Pulaski County. These are some of the counties who participate in the New River Valley Planning District Commission. And then you'll just kind of answer these generic questions. So what is the slope of the site? What is the soil type of the site? And then come up with some recommendations. So as a consultant, Do you recommend that they permit this and allow it to happen, or do you recommend that they restrict it? And I want you to kind of write up a recommendation that uses the maps. So I want you to have your report in a Word document, and I want your maps in the Word document. And you need to label them with figure captions. So call something Figure 1, Figure 2, Figure 3. And then in your write-up say, hey, look, Figure 1 shows that there are, X number of acres of land that will be impacted, and therefore you have some opinion. And so I want you to make this report look professional, like it's something that you would give to a person in the real world. The better you do at these, the better your skills will be when you actually have to do it outside of school. Okay, so to get started here, if we look at this, I can say, okay, well, the region that we're really focused on has something to do with Bradford City, Montgomery County, and Pulaski County. So the first thing that I want to do is get some data where these counties are represented. And so I provided you with a data set where you can extract that information from. It's the census data that we downloaded a few minutes ago. So I'm going to go back to my downloads, and I'm going to unzip that census file. But before I do that, I'm going to go to my documents and make a new folder called Lab 8. No spaces. Okay. And I'll go to my census folder and I'll unzip it. And I'm going to extract it into the Lab 8 folder, which is in my documents. There. All right. Okay, so now we can go into ArcGIS, and we'll start with a new blank empty map. And then we're going to go to Catalog, and we're going to add the data from the Lab 8 folder. I'll refresh my list. Sometimes you got to do that. Okay, Lab 8, Census. Drag this over, and we'll roughly zoom in to the area that we're interested in. Okay, so this is basically census data that's representing counties, and here we can kind of see the shape of Virginia, but what we need is Montgomery, Radford, and Pulaski. So what I'm going to do is I'm going to go in here and I'm going to turn on my labels. It's a lot, and we have an FID used as the label, so we'll go into our properties and we'll go to the labels tab, and instead of using that number, I'm going to use the county, and I'll just hit OK. And there we can see right here we got Montgomery, Pulaski, and Radford. Okay, so I'm going to zoom in, and I will highlight using the select tool and hold the shift key. I will get Pulaski, Radford, and Montgomery. I'm going to turn this into a new layer, so I'll right click, go to selection, and create layer from selected feature. Now I can remove my old selection, and now we have the counties that are of interest. The next thing I'm going to do is I'm going to go out to ArcGIS Online, and I'm going to get some sort of base map. Just because we want to familiarize ourselves with the area, and we might want to know where Crater Lake actually is. So we'll go in, I'm going to use the National Geographic one. Not that one. Got to spell geographic right. Alright, great. And you want to find the one that says add, so the National Geographic World Map works. I'm adding that service. And what I'm going to do is I'm going to turn my counties into a hollow layer so that I can see through it. And right there we can see that Claytor Lake really runs through the middle of Pulaski, but other counties or surrounding areas may be impacted as well. Okay, good. So the next thing we need to do is we need to get a digital elevation model. This is a raster type data that shows the elevation of a piece of land using cells or numbers. So we have cells. Remember, rasters are grids, which is a collection of cell, and each cell is going to have a number in it, and the number is referencing the height or the elevation of that piece of land. So if it said 740, that piece of land is 740 meters tall. Most DEMs represent elevation data in meters, and that's a very important thing to remember. So to get the DEM, we're going to have to go out to the USGS Seamless site. So what I'm going to do is go to Internet Explorer, and I'm going to type in USGS Seamless. I'll go in here, and we're going to use the National Map Viewer. Takes a minute to load. All right, and then we're going to zoom into our area of interest. We can actually see the county outlines, even though they're very hard to see, they're there. And so what we're going to want to do is use the download tool, and we're going to use a bounding box, and we want that box to be big enough so that we get all of the counties in our area. So that right there ought to do it. And what we want is elevation data, so you'll hit next. And if you reference the Word document or the lab document, I want you to use 1/3 arcsecond. So when you hear an arcsecond, that's a unit of measure they're using to tell you the resolution of the data. And so 1/3 arcsecond is higher resolution than 1 arcsecond. So that's the one we're going to go with. And we're going to get the ArcGrid format. All right. So we're going to go USGS NAD 1/3 arcsecond. That's exactly what we need. Hit next. And then we'll go to checkout. Put in your email address. And we'll place the order. We'll wait until that comes through. There it is. All right, great. So we'll go over here and we'll click to download. All right, now while that's running, we're going to go back into ArcMap and make sure we set up a few things. So the first thing you need to do before we run any sort of Spatial Analyst tools is you need to go over to Customize and hit Extensions, and you need to make sure that all your extensions are turned on, or at least the Spatial Analyst one. So I'm going to go down the list, check all my extensions, and if you remember back from my earlier lectures, that enables these tools, or it turns them on so that we can actually use them. So all those extensions have been turned on. Now I can go in and I can open my toolbox, and for this exercise we're going to be using the Spatial Analyst toolbox, right? There's a whole lot of different tools in here that are very useful. Most of them rely on vector or raster based information, so there are very few vector tools. And for today's exercise we're going to really focus on using the surface tools. All right, and so within here we can see that there is an aspect tool. It's exactly what we need to use for a part of this map. And if we get a little bit more detailed help, you can go in and it kind of gives you the mathematics behind it. So we take basically a raster, and so imagine this is some sort of elevation data, and it creates an output raster that gives us an angular or degree-based measurement that reflects which way it's facing, if it's north, if it's south, east, or west. So the input raster must be elevation or a digital elevation model. The same is true for slope. All right, an input raster that's elevation. The output is the degree or percent slope. And the same is also true for the Viewshed tool. But the Viewshed tool is a little bit more complicated because it requires an input point, which in this case would be the tower. And we'll go through how to do that in a minute. But what the Viewshed does is it computes an area that is visible from a given point. So here we have the input digital elevation model with a point on top, and the output is everything that's visible in green and not visible in red, right? So there's a lot of useful applications for a Viewshed tool. Maybe you want to see what's visible from a fire tower. Maybe you want to model where a radio signal transmits to. Maybe you want to model cell phone towers. Maybe there's a proposed development and you want to see how a new high-rise building is going to impact a Viewshed. Well, this is the tool that can help you do it. So it's a very useful tool, right? Okay, so we'll go back and we will check on our download. So it's still going, but that's okay. Now, you know, one of the things you got to be aware of is that the bigger an area that you download data from in USGS Seamless, the bigger the data is going to be. So sometimes you really have to be aware of the size of the data and how long it's going to take, and also maybe what sort of tax that's going to put on your network. But for now, we'll let that try to complete, and we'll move on. All right. So if we go back to the lab document, we can see that we've been given some coordinates for the tower location. And so we need to somehow plot this on the map, right? And there's several different ways we could do it. One thing you guys have already learned is how to create a table and to plot XY data using a table, but today I'm going to show you a slightly simpler tool. If you look up here in your toolbox, you should have a GoToXY Tool. All right, and so we can click on that, and it asks us for an input. Give us the longitude and give me the latitude. So I want you to go back to your Word document, and I want you to copy the longitude, and then go back and copy the latitude. Now, you know, a lot of people mess this up. They don't remember what X and Y is, which one's lat long, and they end up plotting something in the entirely wrong hemisphere. So, you know, just make sure that you know the difference between those two. Remember, longitude runs long, right? Prime meridian is 0 to 80, or 180 on both sides, right? Okay, so we've got the data in here, and now we're going to go, and I want to add a point to where that location is. So I hit add point, and now I've got a spot on the map, and now I can click the zoom button, and well, it didn't zoom very much, but it kind of recentered the map. So I can zoom in here, and we can actually, you know, see now where this spot is in relation to Crater Lake. So, you know, it's not really close, but it's close enough that it might be visible and cause some tourist issues. So to do something with this point layer that we just plotted, we have to get it into our table of contents. The reason it's not there already is because it's been created as a graphic file. And remember, graphics are different than features, but we can convert graphics into features. So what I'm going to do, and before I do this, is I'm going to set my data frame here, because I know that I want to be in UTM, and I'll explain why in a minute. So I want you to reset your data frame properties to UTM. So right click on data frame and go to properties, and we can see right here we're in a geographic coordinate system, but we want to be in projected and UTM, and we're in NAD 83 zone 17 north. And you'll notice that the map is going to give us an warning, but that's okay. And then the map just kind of readjusted. Okay, great. So our data frame's in UTM, but one issue is that our county selection is not. And so a trick to get data into a new projection without running the projection tool is to export that data. So I want you to right-click on census selection, go to Data and Export. And I want you to export the data using the same coordinate system as the data frame. So what this is going to do, and I'm going to call this counties, this is going to export it in UTM. Right? It's a nice trick. And yes, we'll add it to the map. I'll remove the old one, and again make this hollow. All right. All right, great. Okay, so one of the things that you got to be careful about when you run tools is you have to make sure you know what the required input parameters are. So the first tool we're going to run is the Viewshed, which requires an input raster, which is our DEM, and it also requires a point or polyline, which is the observer feature. In this case, it's going to be that point, but that point is not an option yet because it's not in the table of contents. So let's go ahead and do that real quick. So we're going to convert that graphic, as I mentioned before, into a feature. We do this by highlighting the graphic. We have to go to our drawing toolbar. If you don't have it, right-click and turn on Draw. So using the graphic selection, we click on that, highlight it, and then we click the down arrow on the drawing toolbar, and we convert graphic to feature. Right? So one point, we want to use the coordinate system of the data frame, and it's called converted graphic.shape, and I'm actually going to change that and call it tower. And we want to automatically delete the graphic after the conversion. Yes, we want to add it to the map. Now I have tower, it's a feature, it has a projection, life is good. Alright, so now if we go back into our Viewshed tool, remember that we can see that this is an option, but in the instructions it mentions that this tower is 250 feet tall, right? Well, I mentioned earlier that our DEM is going to be in meters, and so we need to do some sort of conversion because we want to keep all of our units in the same, or all of our units to be the same. So if we're going to go with meters, we need to stick with meters. So what you can do is a really simple, Google search. If you don't know the conversion factor, you can just say feet to meters, and it's really nice. And you can actually go in here and you can type in 250 feet. And you can see that it's 76.2 meters, right? Super easy, although it's best to do the math on the calculator. All right, so somehow we need to record the height of the tower in this feature class so that we can properly use this tool. And if I go to Tool Help and scroll down here, I know this because I've referenced Learn How the Viewshed tool works. And if you scroll down here, it tells us. Let's see, where is it? Right here, that there's this thing called offset A, which references the tower height, right? So offset A is the item that indicates a vertical distance in surface units to be added to the z-value of the observer point. This is what we use to tell the computer how tall the observer location is. If it's you standing there, it might be 3 feet. If you're standing on a 100-foot building, it would be 100, right? So if we scroll down a little bit further, it tells us that basically we need a field called offset A, and you got to make sure that it's exactly like this, right? So what we'll do is we'll right-click on Tower, and we'll go to Open Attribute Table, and we're going to add a field, and we're going to call it offset A, just like that. And I like to use doubles because they work in most situations. Now we need to get a value into this field, so we can right-click and go to Field Calculator, and I can type in 76.2, and now we have the required information we need in the attribute table to correctly run the Viewshed tool. So now what we need to do is go back and double check on our download, which is very close to finishing, so we're almost there. Alright, great. So we can now close this table. We got the tower there. So, one thing that I might do before I go any further in this kind of analysis is I want to get a rough idea about the terrain using Google Earth. So what I'm going to do is something we've learned before, is go to Conversion Tools, and I'm going to convert that layer into a KML. Right? It looks good. We'll run OK. I'm going to go to Google Earth now, and I'm going to open up my Windows Explorer, and I'm in ArcGIS, or Documents, ArcGIS, and I'm going to find my tower KMZ, and I'm going to drag it into ArcMap, or into Google Earth, and what it's going to do is zoom to that file. Now, one thing I want to mention is that the tool says it's a convert to KML file, but you'll notice what comes out as a KMZ, and so the KMZ is actually a compressed version of a KML, so you don't really have to worry too much about that. Okay, so it's been plotted, and I'm going to, my terrain's already turned on, so I'm going to rotate the map here and zoom in a little bit. And so we can see that the point that's been picked is actually one of the highest peaks in the region. And while right there doesn't look too sloped, it does look like the land around there is quite sloped, and that there might be some difficulty building a road up there for access. But the consultants haven't, particularly asked us about that. But at least we've informed ourselves a little bit, and we could make some other recommendations using different types of geospatial technology. So always remember that Google Earth is a good complement to ArcGIS. All right, we'll go back, check on our download, and we got about 12 seconds left. All right, it's a zip, so again I'm going to hit extract all files. I'm going to put that in my Lab 8 folder. And hit extract. Now I can go back into ArcMap, and we'll close our toolbox. I'll refresh my Lab 8 folder, and now I have a DEM, or a bunch of different files. Now remember, you can kind of tell the difference between vectors and rasters based off their picture. In this particular situation, we do not want to use the thumbnail one, so you're going to want to use this grid, which should be named similar to what mine was, right? But it won't be exact. So I'll add that, hit yes to pyramids. And let's see, we have a DEM, but we are missing part of Pulaski, which is interesting. So there might be some problems related to the bounding box that we drew on USGS Seamless and what we actually got. So if you actually run into this situation, I want you to make sure that that your download covers the entire area. But for the sake of this exercise, we'll just continue with it as is, just for the sake of time. Okay, so one thing that we want to do as soon as we've added new information or new data is we want to check the projection and coordinate system. So I'm going to right click on here and go to Properties and Source, and we can see here that we're in a geographic coordinate system. And what this means is that the XY units are recorded using decimal degrees, and this can be quite problematic anytime we're running tools using the ArcGIS toolbox. So to show you an example of what I mean by problematic, I'm going to go ahead and run the slope tool. Okay, to to show you what can go wrong if you have XY units in a different unit than your Z data or your elevation data, I'm going to go in here and I'm going to drag in a grid, and we'll just run the slope tool. And you know, it has kind of come up with a Z factor for us automatically. So we can go ahead and run this and see what happens. It's probably not going to work, but Esri does kind of change their how tools work sometimes. So we'll see what happens here. While that's running, oh, there it goes. One of the things I want you to do is to change the symbology of this layer. So go to Properties and go to Symbology, and I want us to use a color palette that is typically used for elevation data. So I want you to go in here and to right click on the color palette and go to uncheck the graphic view so that it's a text view, and you'll notice in here that there's an elevation palette. It's called Elevation 1, and what this uses is something called hyptometry, where things that are low in elevation are blue and high are white to represent, water and ice and the vegetative gradient through there. So here we can see the elevation of all the places kind of in this region, and if we zoom in on Radford, for example, we can kind of see where the river is, and for those of you here or live here, you kind of know that this is an accurate representation of the topography. Okay, so now let's go back and turn on the slope map, and it actually looks like it did work correctly. And this is really because we set our data frame properties to all of our other data, which allowed the tool to kind of automatically compute or think about what the conversion factor should be, but this doesn't always happen. So I'm going to remove that and tell you that the best practice is to convert all of your data into the same coordinate system where the units all match. So we know that we're in UTM over here in the data frame already. If we go to Properties, we can see we're in UTM. UTM uses meters. Our elevation data is in meters, but this is actually the XY's in decimal degrees. So what we're going to do is we're going to use that export trick again. We're going to export the data, and we're going to use the spatial reference of the data frame, right? And we'll just go ahead and hit save, and that'll give us a new raster that's in the correct projection coordinate system. And it should add it to the map. This is a big file, so it's going to take a little bit of time to run. Another thing you want to remember is that the bigger the file, the longer it takes tools to run, which can kind of be a problem. So, all right, so now we got a new raster. I don't like the kind of color palette, so I'm going to go back into the properties, and we'll change it to Elev1 again, because that's kind of the standard for elevation. All right, great. Now I'm going to remove the old one. All right, so now I'm going to rerun the slope tool. Actually, we're going to start with the Viewshed tool first, since this is the first parameter. So we're going to run the Viewshed tool. We've created a field called offset A. Everything's in the right projection. The input is going to be elevation. Then the input point will be our tower. And it's going to give us an output. And notice now how the Z factor says 1. This is because it did not have to make an adjustment for the difference in the X, Y, and Z units. And you can see right here it's talking about what that Z factor does. So remember, best practice is to match your units, and then you don't have to worry about a Z factor. Okay, so I'm going to hit OK. And if you want to see, what processes are running, you can go to Geoprocessing, and you can turn on your Results tab, and it's showing us right there that we have a Viewshed running right now. Now, as I mentioned, some of these things take a little bit of time to run, so you just kind of have to be patient. Okay, so while that's running, we're going to go back here and look at the lab manuals. So you have to make sure for this lab that you have all of the necessary components. So we're creating a report that's going to be used by the Planning District Commission, and we're basically consultants. So we have to make sure that we give them everything we need. So here we can see that we need a viewshed map, we need a soil map, a slope map, an aspect map, and we really need to make sure that we have aerial photography in there somewhere. So you can have between 4 and 5 maps. You might figure out how to get aerial photography into the viewshed map, or you might just make 5 maps in total. But what you do is you make a map for each one of these, you'll export it as an image, and you'll insert that image into the Word document. Some of you guys have been submitting images by themselves. I want you to embed it into a report so that it looks professional, and we'll look at how to do that in a few minutes. Alright, so we go back here, and the tool ran correctly. We can see that all the areas that are this pink, I'll make red, which is a little bit easier to see, are not visible, and everything in green is visible, right? So we're going to drag our tower point on top of that, and we're actually going to zoom to the tower location. And you know, maybe I don't really care about what's not visible, so I'm going to turn on no color. And I'm actually going to turn off my my elevation data, and I'm going to turn off my National Geographic information. And to get aerial photography, I'm going to go to ArcGIS Online, and I'm going to type in world imagery, and we're going to use that layer. Okay, so add world imagery. I'm going to drag that down to the bottom. Okay, great. Alright, so you can see that, you know, most of the lake can actually see the tower, or the tower can see the lake. So there are some things that might be of a little bit concern. A little bit of a concern. So one of the things I asked you about doing is figuring out what the area of the land that affects this place is. And so what you're going to have to do an area computation is you're going to have to use a conversion tool so that we can take this info that's outputted as a raster, and we need to convert it into a vector so we can use our calculate geometry tools. So I want you to go to conversion tools, and we're going to go from raster to polygon. Okay, so I want you to run that tool, and you'll drag your viewshed over, and the field that we're going to use is the value field. So visible is a 1 and not visible is a 0, and if you look in the attribute table you can actually confirm this, right? 0s and 1s, and we have a count, which is the number of pixels. And if you're really creative, we know that each pixel is 10 by 10 meters, so you could you know, multiply that by the count field and get another estimate of acreage. But we're going to use a better way. So uncheck the simplify polygon option because we want to retain the gridded nature of the data, and we're going to hit OK. And the output will be a polygon which is continuous. We're going to see polygons that cover the whole area, and what we're going to have to do is we're going to have to query out the ones that are actually visible by referencing that value field. Come on. Sometimes you got to talk to ArcMap. Okay, while that's running, I'm going to go ahead and get the slope and aspect tool up. So I'm going to go back into my Spatial Analyst tools. I'm going to go down to surface, and the first thing I'm going to do is run slope. I'm going to drag over my elevation data. That's what the input is. Notice how there's no Z factor, right? Because we've done the right stuff. Hit OK. And I'm going to go ahead and run the aspect tool as well, just to speed things up. Again, drag over my elevation, and I'll hit OK. Now if you look in my results pane, I have a slope tool. It's waiting to be executed, an aspect tool that's waiting to be executed, and the raster to polygon tool, which is currently running. If I hit the plus button, I can see what's going on, right? Oop. All right, now it's done. Now that looks a little crazy, right? It's not exactly what we need. But that's because there's polygons for the zeros and there's polygons for the ones. So if we go in here and open the attribute table, we can see the grid code, which is the value, and we can run an attribute query where the grid code equals get unique values and 1. 1. So now we've highlighted all the polygons that were represented by this green color in the raster layer. We've just done it in the vector layer. And so we'll turn this into its own layer by going to Selection and Create Layer from Selected Feature. All right. Now some things popped up in the background. Don't worry about those for right now. Right click, Selection, Create Layer from, okay, there it is. So now I can get rid of that other one, and now I have polygons that only represent the areas that are visible, right, from this viewshed. And so one of the things I said that I want you to do is to tell me the amount of land that is visible, but I don't care if it's out here, you know, in Giles County. I want you to make sure that it's only within those counties of interest. Just keep in mind that my elevation data was slightly clipped or cut off, so our values might vary a little bit. But you know, for the demonstration part of this, it's fine. So to clip a raster or a vector layer, we can go up to geoprocessing and we can go to clip. And what we're going to want to do is we're going to want to use our input is going to be the viewshed selection, and our clip features are going to be the counties that are of interest. And what that'll do is it'll cut out only the features that we care about. So it'll show result in only visible places within the counties that we have. So clip is a very useful tool. It's kind of similar to the erase tool, but it basically does the opposite. All right, so now we can turn off our old layer. I'm going to make this color green so that it's really easy to see. I'll make it a bright green. I'll hit OK. And I'm going to turn off my raster viewshed. And so the only thing I have now is see how it's cut off everything outside of the counties. So I've clipped it so that I only have visible places within the counties, right? And now what I can do is I can go into my attribute table. I can add a new field, call it area, make it a double, and we can right click, we can calculate geometry, we can do area in acres, and then we can summarize or get stats on that data where it gives us a mean or a sum, which is the total number of acres. Yours should actually be slightly higher than the one you saw there. Okay, great. So that's basically done the first map. We've computed the viewshed. You have an acreage estimate, and so I want you to turn that into a professional quality map, right? Make sure it looks good. Now, while we were doing that part of the analysis, we had some other things running and executing. So the other layers that came up are the slope layer, right? This represents the degree of slope, so how steep a piece of land is. And if we zoom in over here, we can see this river area, right? If I turn that off real quick, you can see in the world imagery what I'm talking about. See the river, and right here we have a very steep cliff, and over here is kind of the 100-year floodplain, which is a very gradual transition out from the river. So if we turn the slope back on, we can see the areas in red are very steep and green is relatively flat. So what this tells me is that the slope tool has run or executed correctly. And if we're going to turn our tower to black so we can see it, and then if we right click on it and zoom to that layer, we can zoom in very close, and we can actually identify, using the eye tool, the slope of that particular cell, right, or grid. So I clicked on it, I identify the slope layer, and it gives me a pixel value of 6.3. So that means it's 6.3, I believe we ran it in degrees. And so if you're not sure if it's in degrees or percent slope, you can go back to your surface tools and slope, and by default it's set to degrees. So 6.3 degrees isn't terrible. Just you want to make sure you run it and confirm that and determine whether or not you think that's suitable to build on. The next thing we can do is we can turn on our aspect, and we've identified that this particular piece of land is northeast facing, so it's on the northeast side of the mountain, right? And there may not be any huge kind of yes or no decision based on aspect, but I wanted you to at least run the tool and be able to identify what the aspect of that particular piece of land is. So we're moving along very quickly here. So we've got a viewshed map. You can turn that into a professional map. We did slope, we did aspect, we've got an aerial photography from ArcGIS Online. So the last thing we need to do is to get a soil map. So I want you to use the USA soil survey data from ArcGIS Online. So you can right click and we can copy that. We can go back to ArcMap and go to File, ArcGIS Online. We can paste in that name and search for it. And you're going to want to find the one with the add option. And I'll turn some of my other layers off here. I'll zoom out a little bit. Sometimes ArcGIS Online services take a while to stream, and this is just because it's being beamed across the internet, and it's tough. So here we can see that the map is actually telling us that it's this this is the type of soil that's in that particular area. So what you're going to have to do is a little bit of research and see if it, if you think that's a suitable soil. You can also click here right in that area and identify the polygon, which gives us much more detailed information about that area. So it's highly erodible land. Well, that's all it really tells us. It actually claims it's on a 15 to 25% slope, but we know that's not exactly true because we're on the top of the mountain. But we do know the type of soils that are there, and we know that they're highly erodible. So you'll have to kind of make a decision on your own as to whether or not that's suitable for building or not. And again, I want you to make a map using the soil data that you've gotten from ArcGIS Online. So we'll have a bunch of different maps that you can use to inform the consultants. Now don't forget to make your maps. You go to the layout view, you insert all of the map components such as title, north arrow, sketch engine, scale bar, and then you, let me go back here, then you export that map as an image and bump the DPI up to a minimum of 300 so that it's not pixelated. Put that in your Lab 8 folder. All right. And then when you're in Word, we'll just go to Lab 8, and you want to embed a map, you go to Insert, Picture, find the picture. It's not there yet. Always give it a better name than I just used right there. It's interesting. I'm not seeing it in my list, so I'll close it. I'll insert picture again. So, did I save it in the wrong place is the question. I don't think so. So I'll go to my Windows browser, go to Documents, and scroll down to Lab 8. And it's not popping up, which is quite interesting. So we'll go back here. Go to File one more time. Oh. And export, because it keeps telling me the export's complete. I'm just not seeing it. So where did it go? And we can see it actually went into my Documents folder, which is a mistake on my part. So always really pay attention to where you're saving these things. So I'll back up one, and I'll find my untitled JPEG, which I exported today, and I can insert it. And now I have a very high quality map, right? And you can go down to the bottom of it, and you can type in figure captions so that you can refer to them in your write-up. I'm not giving you a page requirement on this, but I want you to completely explain yourself and make sure that you answer these following questions, whether or not it's in your write-up or as individual components. So we've done a lot of really neat things today. We've learned how to run several tools in the Spatial Analyst, and if you continue on in your GIS education and take intermediate or advanced GIS, we go into much greater detail on some of the tools in the Spatial Analyst toolbar, as well as the Spatial Stats toolbar, Network Analyst, and the list really goes on. So that's all for this lecture series. Thank you.